to see if I'm actually streaming. 1 second. If you are joining in now, this is just a test. To see if I am streaming or not in the Python. So let's see. I can't quite tell. For those joining, I am just testing to see if I'm even streaming. So 1 second as I test. Do you mind going? Can you see me? Yeah, I got that one. It takes like a second. Let me see. What'd you say?
I can try it on a phone.
Okay.
Yep, I see you.
You see me? Okay. Awesome. Thank you. All right. Hello, everybody. Oh, can you check the sound? Make sure it sounds good. Can you check the sound and make sure it sounds good? Oh, okay. Okay. Hello. I guess I'll get started in the slides. So we'll be doing text classification in Python, and this is the Women Who Code DC Python chapter. So a little bit about, I guess, Women Who Code is we are a global nonprofit dedicated to inspiring women to excel in technology careers. We work to support this generation in being and becoming leaders and role models in the tech industry. So we are the DC chapter, but there are over, I think, 60 chapters worldwide and over 180,000 members worldwide and counting. So we have a really strong international and supportive community. If you want to volunteer or donate, you can visit you can go to www.womenwhocode.org and then look for DC, and you can see ways to get involved. If you want to join our Slack, that's the easiest way to tap into our chapter, and it's right here, this HTTP, this bit.ly, WWCDC Slack. And a little bit about this Python chapter. So I am the Python director, and so the first Wednesday of every month will be like a beginner Python, and then the third Wednesday of every month will be a more like advanced lab. It's been a bit of a crazy year, so even though this is not necessarily the third Wednesday of the month, I'm just happy to be able to be doing a lab, and hopefully we can return to our normal schedule 2021, but we've pretty much been averaging around 1 or 2 labs a month. And so we have some awesome volunteers. So if you want to volunteer to be either a TA or lead a lab, if you feel confident about your Python skills or want to share something about you learned in Python, I'm always open to collaborating and hearing cool things people are working on. So I would love to hear more about how you would like to contribute and how you'd like to get that done. So I'm Brianna, or Brianna McGowan. I am, again, in the director of Python. It is a volunteer position, and all the positions in the DC chapter are volunteer. There is like a global, like, one who code. So each, I guess, chapter is consisted of directors, leads, TAs, enthusiasts, and I think they call them like code evangelizers or something like that, which I'm not entirely sure what they do, but it seems to me like someone who just participates and attends things. You can find me on Slack at Brianna McGowan, and you can find me on Twitter at Code2Move. So a little quick overview about this lab. Actually, before I go into the overview, I'm going to just see how the stream is going. So, oh my gosh, there is like the toxic, the doom. How do I access the chat from my OBS? Hang on a second. I want to see chat. Awesome. So I'm just going to type hello. Ask your questions here. One thing that I think is crucial and would make this maybe more enjoyable for y'all is if you ask, more questions, make this interactive. Otherwise, it really is just me talking to a quiet room. So I would love to see what y'all have to ask. And just out of curiosity, I want to see who's new, who's returning, whatever. So type in the chat 1 if you are brand new, this is your first lab, and type in the chat like maybe a 2 if you've been to a Python event before, and type in the chat 3 if you just have been to a Woman Who Code event in the past. And I would love to see like who all is new, and welcome if you're new, and if you're returning, glad to see you again. 3, so you've been to a Woman Who Code event in the past. That's cool. 3, oh, awesome. Welcome to DC. 1, well, Lena the librarian, welcome. So excited to have you here for your first. Elvita, yes, hey Elvita, nice to see you. This is your first advanced lab, but you've enjoyed the coding events in person. Yeah, I gotta say, it's a bit different not being in person. It's just so much more electric and exciting to be in person because you can actually really get into conversations and meet people. But I really appreciate y'all being here. So yeah, let's go ahead and get started. In a quick overview. Also, I will be drinking a little wine as we go throughout this lab. What is natural language processing? So also known as NLP, that's kind of like the hot buzzword in data science, if you will. It's a branch of artificial intelligence that deals with the interaction between computers and humans using the natural language. Meaning, NLP tries to mimic how we use our language to kind of tell the computer what's going on, versus like anywhere from classifying text to understanding meaning. So the ultimate goals of NLP is to read, teach a computer to read, teach a computer to decipher and understand, and ultimately to teach the computer to make sense of the human language. Some applications of NLP would be text classification, which is what we'll be doing in this lab. Other applications is just to generate text, like generate paragraphs and stuff. So this is definitely super popular, especially with GPT 1, 2, and 3. Sentiment analysis, NLP is great to understand, if something is mean or happy or funny, and that's kind of what we're doing with text classification as well, is a little bit sentiment analysis. Spam filters, so if you have like spam in your email or even texting spam sometimes, or even on your social media, you can filter that out, and it's usually using a NLP algorithm that determines based off of the text of something whether or not it's spam, and really finding keywords that could be identifiers of what spam may be. Other applications be email classification, so like primary, you know how in Gmail you have like your primary, social, whatever folders? That is actually being generated by an NLP algorithm that kind of reads in the text of an email and then determines whether or not, or even the subject line, and determines whether or not it should be considered primary or social or promotional or something like that. Texting, autocomplete, autofill. There's a lot of like softwares now that have gotten super popular with helping people with grammar and with trying to predict what the end of a sentence might be based off of the first X amount of words, which is pretty cool. And I actually used to hate autocomplete, but it's gotten a lot better, and I feel like autocomplete is easier and more intuitive to use now, which is really cool to see the advancement of NLP over the years. And another application are chatbots. A lot of websites have chatbots. There's even chatbots on our phones. One super, when we like interface, I guess, with whoever we call, sometimes there'll be a chatbot. And they've gotten a lot better too, although I'm pretty sure it's still really frustrating for a lot of people to interact with the chatbot still. So it just goes to show that we're not like, it doesn't feel like we're interacting with the super advanced technology, even though we are pretty far from where we've come, but it also is exciting to see what could be. And there's so many other applications of natural language processing. These are just the few that came to my head as I was making this deck. So the purpose of this lab, so we will be using the SVM, support vector machines, and that is basically like an algorithm to classify tweet text. So we got our data from this Kaggle. I put the link here at the bottom of the slide, and I kind of changed it so in Kaggle they classified text as positive, neutral, and negative. And I decided to classify things as whether or not it's delicious or toxic. So that's what I mean by adding my own flavor, is we're going to be creating a model that can generate or predict whether a tweet is delicious, meaning is it positive, is it encouraging, is it delightful, or is it toxic, meaning is it degrading or negative or disgusting or whatever. So we'll be using SVM to classify tweet text. And we'll also use stochastic gradient descent, which is a neural network to optimize the text classification. And so I kind of have here, just in quotes, something I pulled from an article because I was also like trying to figure out what really is like gradient descent. And so this Towards Data Science article explains it really well. But in a nutshell, gradient descent is an iterative algorithm that starts from a random point on a function and travels down its slope until it reaches the lowest point of that function, and then it tries to optimize that distance. So that's what gradient descent is. Some key terms. Natural language toolkit, or NLTK, is a leading platform for building Python programs to work with human language data. So NLTK is what we'll be using. It's also a library that we'll be using for kind of like identifying words and things like that. It's a really handy library that is famously used for a lot of natural language processing scripts. Vector. So word vectors are simply vectors and numbers, or vectors of numbers that represent the meaning of a word. So and I'll show you this throughout the lab, when we go to generate whether or not a tweet is delicious or toxic, it's actually giving us an array, and it's a vector. It's actually numbers of what the computer thinks it is, and then we have to transform that vector. We have to devectorize it to text data to match our tags. And I'll go about that in a little bit. And model. So there are so many meanings, or so many definitions, I should say, of what is a model. But basically, it's about how do we create a program to achieve how someone would go about a process or whatever. How do we program it? And if you have a better definition of model, super curious to know. I mean, comment in the chat what you think a model is, because I think there's so many definitions out there. So let's get into it. So we'll be working on the example that I have in the meetup. So it's basically from this repository, and this is my personal repository, Code to Move. So this is a project I did a little bit ago, 2 months ago, and had a lot of fun doing it. And so this is the repository. So I will be copying this in the chat. And yes, I will be sharing the notebook later. One reason being is that, so the notebook is in here, so I'll be sharing the repository. So I will kind of just walk you through this lab, but I will be running it in real time and doing that so that when you take it home, you can tweak it, play with it, whatever, with your own repository. And that is the link there, that GitHub repository to this lab. Okie dokes. Okay, example time. So this is a preliminary installation. GenSim is a natural language processing library. I'm just going to run it. It takes a bit to install, but once we have it installed, we'll be using it, at least I think, if I remember correctly. So remember, this is, I don't know, a rather preliminary step is each time make sure to run your imports. I sometimes forget that, especially if I'm returning back to a code. If you don't have your imports in your libraries, your code won't run. So let's go ahead and run this cell. And that also might take a little bit to run. And as that's running, the next thing we'll do is read in the CSV of the pre-matched tweets to tags. So what we'll do here is we'll create a data frame, and we'll call on our pandas library to read in our CSV, and we say read in the tweets.csv, and the tweets.csv is also in this repository here. It's right here, tweets.csv. And we want to take away the nulls so that we aren't thrown any errors. And then we just want to read in the top 10 rows of our data frame just to see, what it looks like. And, I always have a good time with this because these tweets were, pulled from Kaggle, and they were just scraped off the internet. And so I just have a lot of fun just reading them. An inspiration in all aspects, fashion, go team, literally beautiful just the way you are. Yes, beautiful album from the greatest unsung. Good luck to Rich. OMG. He kissed, crying with joy. Happy anniversary, me and Poppy, love, love, happy. Music feeds my soul. Dancing in my room, feeling happy. So these were the tags that were pre-labeled, that I have pre-labeled as delicious, meaning they are delightful, they're fun, they make you smile maybe. And so the computer doesn't know that this is delicious. We have to say, hey computer, tweets like this are delicious. And I think there's over like 10,000 tweets that I pre-classified, or I guess pre-labeled. So we wanted just a nice, healthy training set. And so basically, I'm telling the computer, hey, every time you might see "go team" together, every time you might see "beautiful" or "yes" or "good luck" or "crying with joy" or "happy" or music, soul, dancing, those would be pre-labeled as delicious. Yeah, sorry, how did I relabel them? So basically, I literally went in myself and I determined whether or not something was delicious or toxic, and it was just an easy kind of one-to-one. I only used the positive for delicious and the negative for toxic. So those are the two that we're working with from the Cadwell data set. But if it was positive, I basically said, you know what, I'm going to make this delicious because I think it's a funner word to work with. And if it was negative, I just relabeled it to toxic because I think that was a better descriptor or better text classifier, if you will. And that's something that's really cool about NLP is you can always change your text classification if you, so I did it manually. Yes, and that's how a lot of pre-processing, I think, goes, is that before you even generate stuff, you do have to manually label something before you are able to generate with new data what the computer thinks is delicious or toxic, if you will. So you always have that agency to determine whether or not something makes sense, if it's classified correctly, and if it's not, how can you classify it better, or how can you classify it funner, if you will, more fun. You're welcome. So we read in our CSV, gonna run this. And now my tags are delicious and toxic, so I just assigned it to this variable. And I'm gonna make a bar plot basically of, and this is how you set your bar, your plot. I basically want to see count how many delicious and count how many toxic tweets I have. And so I think there is a little bit more delicious than toxic, which is fine. But what's good to know is that this is a balanced data set, meaning we are working with almost equally delicious and toxic tweets. And that's important as we go about, classifying, is we want to make sure that we equally classify one thing and allow the computer to be able to distinguish it from another thing and have the other thing equally classified, because we want to optimize our model as to when it should choose this classification versus this classification. And the more balanced your data, the better the model performs. Sorry, I keep going back to that. So now we're going to create a function that matches the tweet and a tag. So right now, our script is, even though we might have our pre-matched, tags and tweets, our script does not know that they actually go together. It's just reading them as two different columns in a data frame, and we want to say no, they are matched together. Anytime this text happens, it should be matched with this, and anytime the other row happens, like anytime go team happens, it should be matched with delicious. And anytime literally beautiful just the way you are happens, it should be matched with delicious. So we're going to create a function that matches our tweet text to our pre-assigned tags. So we're going to create a plot, basically plotting the kind of zipping up, if you will, the tweets and the tag. And we say, if the example, in our example is our tweet. So we're going to go into our data frame by index, and we're going to get our tweets and our tags. And if the length of that example, meaning the length of our data frame is greater than 0, then print the tweet and tag together. And it basically, this function will stop once it's reached the length of our index. And so our index is this. So in a data frame, it automatically indexes our data. So we want to go the entire length of the index here, and the index corresponds to the rows. And so for the entire length, for the entire index, we want to kind of match the tags to the tweets. So I'm going to run this function, and then I just want to print a plot. And this is already set for the 10th index. So I don't think, so let's rerun this, and let's do head 20 so that we can play around with this function. So the 10th index is join the vote for singer, spread the word, delicious. And in this, it literally just matched our delicious tag to this tweet. So we can print any plot we want. So let's do the 15th plot. Went to work, don't get too excited. Let's plot the 5th. Good luck writing to rich. Can you donate? Second one, literally beautiful just the way you are. So now that we have matched our tweets and tags, and we just printed this plot just to see how well it did, and we went through a couple iterations of are we matching our tweets to the tags. So now we'll be using our stop words. Stop words are basically anything that doesn't lend to the meaning behind, to the meaning of a text. So sometimes we'll have, let's actually do an example. 11. So we're going to print plot 11. Thanks for the great review, smile. So stop words are like your prepositions. They're your if, ands, buts, of things. Stop words, you can also add to your stop words, but the NLTK stop words, and remember, NLTK is from Natural Language Programming Toolkit. So basically, NLTK has stop words in it, and so we're just going to use what they have. But you can make your own stop words. So anything that you feel doesn't really add to the meaning of something, it basically is saying don't count these words when you're processing the tweet text. And now we're going to do some cleanup in the text. I'm also going to pause real quick and see how, yeah, we're just printing it. This function we will be calling upon a little later. So right now we're just printing it just to see if it works. We're printing it just to see the outcome. And so now we'll clean up the text. I'm going to take a sip of wine. So these first 3 lines are basically taking out weird characters, bad symbols, anything that might take away or obstruct from the cleanliness of text, meaning anything that might make the model perform worse, we just want to take out, meaning we want to take out those slashes and the parenthetics. We want to take out brackets and at signs and semicolons, and we also want to take out just bad symbols like hashes and carets. And then also our stop words, again, are also things that don't add to the meaning or value of text. And then we're going to go ahead in here and define a function to clean our text. So basically we want the text to be a string, and we want to return the modified initial string or modified text with our clean text. So this text here is Beautiful Soup, and Beautiful Soup is a web scraping library. It's a good text parser, and it's an HTML decoder as well. So we'll be doing some HTML decoding. So anything with like hashtags, as you know, Twitter data has a lot of hashtags, so we want to be able to decode that and also remove it, as we did up here. We want to make all the text lowercase. This is just good practice to make all text lowercase in our data set and have our model just train on all lowercase data. We want to replace spaces. We want to replace the symbols with spaces. So anytime there's like a symbol, instead of the symbol appearing, it'll just be a space. So we're basically telling the computer, don't see this symbol, keep going, type. And we want to actually delete symbols which are from our bad symbols right here. Deleting bad symbols from text. So this one replaces with spaces, and this one just deletes the symbol. And this deletes the stop words from text. So basically we want to join, anytime there's a space, we want to just join that text if the word does not appear in our stop word. So this is kind of like a little for loop within this variable, meaning we're going to split our text, and anytime we see a stop word, it will be removed. If it's not removed, it will be added back to the text body. And it goes through this for the entire string and then through the entire data frame. And then we just want to return our clean text. And this function is just basically cleaning up our text so that we can have nice, uniform, clean data to work with. So I'm going to go ahead and run this function. I'm also going to look at my chat. Okay, no questions. I shall keep going. So now I will use this clean text function to clean up the text in the tweets column of our data frame. So I'm going to call in my data frame again, and I'm going to specify which column I want to apply our clean text function to. And I'm saying, clean text function, clean up this tweet column. And replace that with the current column. So I'm basically kind of saying I'm reassigning the column to a cleaner text column. And they're still matched, by the way. They're still matched to the tags. So I'm going to run this. And now I'm going to print our plot, which was the one that we had, 11. So I'm going to print plot 11 now. So this basically says this is different than our original text because we took out the exclamation point, We made everything lowercase. Let me see if I can find a really wonky one that, okay, 19, that, you know, just might not be the cleanest data. So I'm going to print plot 19. So our original text, oops, we had that smiley face and this exclamation point and this exclamation point, and we've got some all caps letters. We basically got rid of that with our function, where we took out that smiley face, we took out the capitalized letters, and I'm also noticing this. So the fashion icon. So going forward, it would be great to actually maybe put the as a stop word, because it's not really helping to the meaning of 6 plot applicable team hire fashion icon. The doesn't really mean anything. Actually, this text is really confusing too. So I feel like adding more to the stop words makes your model better if you want it to be a really strict model. And I know quite a few people who have really, really long list of stop words. I know people who only have like of, and, by, to. So it just depends on what you're trying to achieve with this. And so now I want to see how many tweets we're kind of working with. So I apply this lambda function, and I say for the length of basically the tweets, I want to see how many different tweets are we working in this column, in our tweets column in our data frame. And so we're working with 13,561 tweets. Oh, and this is just adding up all the tweets. So it's basically like just going through and counting them and then taking the sum at the end. And so these next steps include feature engineering. And the reason why it's good to see how many tweets we're working with is just to get a better sense of how much data you're working with. It's always good to know. The next steps include feature engineering. So convert titles to a matrix of token counts, which is count vectorizer. Then transform a count matrix to a normalized TF-IDF representation, or TF-IDF transformer. Basically, we want to split our data. So I define X as the tweets for my data frame, and I define Y as our tags for my data frame. And I basically say I assign them X and Y will be in train test split is a function. And when you call that function, it says train on my X train and my Y train, and then I want you to test on my X test and Y test. So I'm going to run this, and this basically split our data up in order to take a chunk and train, and then leave a little bit to test. Now I'm going to pause there. Yes. To Neha, just, feel free to pause, or to ask me to pause, or take a short break if you need it. Ooh, that's a great question. So is the number of tweets or total number of words? You're right. It's a total number of words. I'm so sorry. If I said total number of tweets, basically Elvita is referring to this right here. It's a total number of words we're working with. I didn't mean to say tweets. I just want to see how many words we're working with. in our entire tweets column. Train test split is basically a function that knows to take our training data and take our test data, or take an entire data set and split it based off of the variables we assigned. So X was the tweets and Y was the tags. And we basically assigned the training to X train and Y train, and the test to X test and Y test. And we want that function takes the training data, trains our model on it, and then we'll use our testing data and then to test our model. Random state, I feel like, yes, so Neha just, nice job, Neha, yeah. Ensure that we get the same value every time when working with random states. That's correct. Okay, so I'm going to run this. And this is not seeing the accuracy of linear support. This is basically just import. Import our necessary libraries. We've already imported, by the way. We did that at the very top here. I just brought down the import again, just to show y'all that this is the libraries that we'll be using to classify our data. So we won't be manually making our model. We'll be using a library and package that that already has, like, I guess, the algorithm for the model, and we'll just be training our data with that algorithm, if that makes any sense. So we'll be using the stochastic gradient descent. Pipeline basically is saying order this. So it's basically kind of like just as it is, like first do this and this and this, and we want to vectorize, meaning we want to take our data and vectorize it and assign it a value, or what the meaning of the word would be in number form. And then TF IDF transformer basically transforms the vectorized text back into text. And SGD classifier is our model. So we take our model now and we want to fit it to our X training data and our Y training data. And then we get this, which basically kind of tells us how the model fits, like its features, if you will, if everything's in lowercase or not, can it actually analyze words, and how will it give us the, what's the word? The vectorized output. I'm going to pause there. Okay, no questions, I shall keep going. And then so let's see what the algorithm generates. So we take our X test data, so we call upon our model, I should say, and we say we want to predict tags based off of our test data. So this right here is kind of training our model, and now we want to test it. So we want to see the accuracy. score of our predicted y and our y test. And we want to print basically our what's called a classification report. And our target names are my tags. And remember, my tags we defined earlier here. So that knows to generate delicious or toxic based off of what it was trained on. Oh, where am I? Where am I? Here. So delicious, every time it was something was identified as delicious, this means the model was about 88% precise and about 95% precise for labeling toxic. Pausing. So we essentially vectorize. Like the point of vectorizing is the computer isn't taking in, you know, like a text. It is taking in text, but it's basically having to transform it to something the computer will understand. So it's kind of like a translation, if you will. So even though it might be, say, delicious to us, we have to vectorize it so that the computer can actually assign it a matrix that it can understand. And this is what gives meaning to the, I guess, computer, if you will. And then when we go to generate something, or generate a tag for a tweet, the computer will generate it in the language it knows, which is vectorized, which is a vectorized generated tag. And for us to understand it, we have to then transform it back to text. So that's why it's basically telling the computer this is what you're seeing in its language, and then we're translating it back to our text language. And Neha just explained TF-IDF generates a text-weighted matrix for the text, meaning that is kind of like the computer's, if you will, language. So it's like a weighted matrix. And we want to then, when it's generated, we will get a weighted matrix that's generated, but we don't understand anything about this matrix. This matrix doesn't really mean anything to us. We need to transform it to text to understand what that matrix is saying. So the computer is able to generate for us, but we have to make sense of it. If that answers your question. Yes. So yeah, the pipeline is vectorizing, running the model, and then doing the TF-IDF at the end. Yes. All right. So now that we've trained and tested our model, and you know, I should pause here and say there's different ways to train and test your model, and different even models to use. We use the SGD model, like stochastic gradient descent, but you could use what is it called? Natural Bayesian or Bayesian natural model. There's also the SVM, support vector machine model. There's different types of models that you can use for text classification. There's even like random forest modeling that you could use. So it really just depends on the accuracy you want and the performance you want. And I think it'll be really interesting to even do like a lab just comparing the different types of models. That would be great. So now we're going to upload the new data to feed the model for prediction. So now we're uploading completely new text tweets. So without the pre-assigned tag. So now that we've tested our model and trained our model, now I want to see how it assigns tags to new text. Yeah, I just created a new data frame here with our new tweets.csv. So we're gonna, but before we can even run our model on this, remember our model has been trained and tested on clean data, which means we now have to call upon our clean text function again to clean our new text. So I'm gonna run this, and this basically cleaned up our text for us. And so we want to see how does this new data look. And as you can see, it took out all like the periods, it took out the capitals, and it made everything lowercase, took out the unusual characters, things like that. We also want to see, again, how many words we're working with our new data set. So I'm going to run this, and we're working with 7,334 words. And now we want to assign our tweets to a variable. And the reason why we're doing this is because we want to then predict upon this new tweet data, and we want to predict tags based off of our trained and tested model. So now we're going to use our model to make predictions for our new input. So we say X new data. We want to call upon our model that we have trained already to predict what our Y new data or our tags should be. So I want to print it out just to see how it does. And so this is our data, and then here are the tweets that it was assigned. Tags it was assigned. And so this is just not, I was just showing this just to see how it does. But now we want to format it to actually make it a little bit more digestible. So we'll have we'll create a data frame with the new data and their predicted new tags. So we'll use dataframe.insert to add a new tags column, and we'll populate that new column with the Y predicted data. And then we just want to see the first 20 rows of this new data frame. So this is the new data that this is new tweet data that we read in. And then our new tags are the generated tags that our trained model generated. So here we have survives, removal, scare. That's good. That's delicious. Court orders probe corruption charge. Maybe this should have been assigned toxic. I don't know. Supreme Court quashes criminal complaints. I don't know. Delicious. Art Livings fights back Yamuna floodplain damage. Again, maybe it's contentious. Should this be delicious? Should this be toxic? Livid. Let's describe it as delicious. Doctors are delicious, apparently. Pharma companies opposing names is delicious. So obviously, our model may not be actually performing the as good as we want it to be, but there are ways to go about like tweaking our model, setting a threshold of what we want our model confidence to be. Do we want it to be 80% confident, 90% confident that this is a delicious tweet? And if not, should it default to something else? It's always interesting to see how the models do. And then this is just saving the data frame to a CSV to just to save the output of our trained model. Example time. So that kind of concludes this like rather beginner intermediate NLP exercise. Some more advanced things you could do is choose maybe different models to use. Another thing you could do is to set tests for your model. So basically, if creating maybe conditions for it as well. Even using multiple models and going with the best performing one is interesting. Yeah, I agree. A lab comparing the different models. That's definitely something that I would love to see, and I feel like a lot of people in the Python chapter have kind of, we've actually chatted in the chat before, like different models to use, why someone would use one model versus another. So I feel like there's a lot of opportunity to kind of determine which model we should use, why. Are we going for performance? Are we going for accuracy? Things like that. Okay, let's see. So some resources. Also, I should also pause and just get a sense of maybe a future lab. Would you like a 2.0 of this lab? Maybe even comparing different models. Maybe even a lab showing how to go about making the model better. Comment in the chat, like, what kind of NLP exercises would y'all like to see in the future? Even if you want to do a different one, like this was text classification, perhaps y'all want to see sentiment analysis, maybe. There's also a lag, so I may not be getting this in real time. Just want y'all to know that. Ooh, so you'd be interested in sentiment analysis, Jess? Okay. Going into model details, comparing would be great. Yeah, I think we should just have a lab just based off of models. What they're doing, what they're up to. Tuning the model. I think, I'm going to make a note, I think a 2.0 of this lab would be how to refine and tune the model, and I think that would be really interesting to do. Making note of that. All right, so let's go into some resources. So our Women Who Code OCR handwriting. Oh my gosh, no, I did a OCR handwriting thing for work. Super interesting. I think that would be something I could show everyone, because basically what we did was we used neural networks to be able to distinguish whether or not someone's signature was authentic or not. And we used the MNIST dataset, which is a dataset of all like different ways you could write numbers and characters in the English language. And that was a really fun task to work on. Which is also how people are doing even some voting stuff, like whether or not a signature is authentic or not, is how we're doing verifying if someone's ballot is legit, which is, I think, awesome and also scary at the same time. So yeah, okay, I made note of that. That should definitely be a lab that we do. Super excited about that. The handwriting dataset is called the MNIST dataset. I just typed it in the chat. So our Women Who Code Python GitHub is awesome. All of our amazing lab leads and TAs have contributed to this GitHub, so it's really like this amazing place where you can go and find different projects to work on. We've done stuff, I think this is like one of our couple first NLP labs, but we've done a lot of data science labs. We've done a lot of like understanding dictionaries and lists and even data structures. We've done automation in Python. We've done some quantum computing in Python, which is a really fun and interesting lab. So definitely check out our GitHub, which I'm actually going to post it in the chat here, because that's one thing I'm very proud of is our GitHub. We've done one on Elasticsearch, conditionals, Flask, like creating apps and stuff. Yeah, just really cool stuff. I feel like it's a wealth of knowledge there. Inspiration for this lab was just my personal project, Delicious or Toxic. And be sure to sign up on the Women Who Code Slack. Also, if you're interested in, and this is kind of in the theme of Delicious or Toxic, if you're interested in maybe like advocacy and getting involved in, say, like fighting for different like issues or different ways to be creative about how we go about our democratic processes or structures or whatever, I'm also a co-director of Delicious Democracy, so check us out on Instagram. It's at Delicious Democracy on Instagram. And we do a whole bunch of cool projects. Our latest project right now is ranked choice voting. So Ranked Vote DC is our coalition that we're building. So thank you. If you have any questions, you can find me on the Women Who Code DC Slack at Brianna McGowan. And yeah, that concludes this lab. I will leave it open for, oh yeah, Elasticsearch. Yeah, the Elasticsearch lab was one I did, I think it was like a year ago now, and it was a really cool lab. We did Elasticsearch to Shakespeare data set, which is interesting. All right, I'm gonna leave this open. If you want to ask me any questions, I'll be here for like the next 3 or so minutes. So feel free to ask me any questions, from volunteering to what you liked, what you wish I did more of. Yes, and thank you. Shout out to Neha for being an awesome moderator today. Thank you, Neha. Literally, you are amazing. Thank you for moderating this. I really appreciate it. All right. I'm just going to say thank you to everyone, and then I'll stop the stream. Y'all have a good night. Take it easy. Take care of yourself. I know this week is insane, and so will next week. Just remind yourself to breathe deeply, meditate, and don't be afraid to ask for what you need and what you want. And to also take care of yourself and other people. All right. Take it easy, everyone. Bye-bye.